So I'm gonna talk less about the FileCatalyst product and more try and educate on why there's the need for acceleration in the first place, what's wrong with FTP and TCP that FTP is based on and SFTP is based on, and HTTP, for example. So for many of you, maybe you know the problem and you're well aware of different solutions out there. I'm gonna kind of just walk through it, and for those that don't know, and then I'll give a very brief overview of the types of options that we provide, but it's the bulk of it's going to be just educational. So again, I'll start with probably an overview of TCP and just the very high level stuff on how it works. I'll talk about the issues of file transfer with TCP, how you can do acceleration with UDP. So we'll move into some different options that you'd have with UDP for file transfer, not just FileCatalyst, but obviously Aspera, and I'll mention some open source alternatives as well. Talk about some considerations if you're looking at implementing a UDP-based file transfer system, things that you should look for in the system to make sure that it's going to work for you. And then I'll talk about different ways that you can integrate it into an existing DAM solution. And then I'll give just a brief overview of FileCatalyst, our technology. It's only one slide, so move on. Just a quick introduction of myself. I am the co-founder of FileCatalyst, Unlimi-Tech. We were founded in 2000, and we're across vertical. So we have a lot of clients in media and entertainment, but also in print. We have a lot of customers in mining, energy, medical, all across the board. So TCP. So everybody uses TCP. The internet's pretty much founded on TCP. TCP is very reliable. TCP is very serial at the same time. So what it provides you is a way to send packets and not worry about whether they're going to arrive. It takes care of all that for you. It takes care of reordering to make sure they come in order. It has congestion control built in. So when many people are using the network, you're not going to have one person taking all your bandwidth. Somebody else can come in and it shares it equally. You add another person and it shares it equally. TCP is the reason why the internet doesn't come to a grinding halt. Without TCP, if everybody were just using UDP for file transfer, you'd have a lot of issues going on. So it's good for a lot of things. It's good for web browsing, it's good for email, it's good for file transfers as well, as long as they're not over geographic distances. So it provides you with sort of the foundation of the internet. Everything that you do is based on TCP. Even our product, FileCatalyst, uses TCP for a control channel to set up the transfers, then the actual transfers get done with UDP. So the basic problems with TCP are that its reliability and its congestion control and its ability to kind of scale back and keep things from falling apart on the internet are also the reasons why it can't go fast with high latency networks and with congestion or packet loss on the network. So it limits the flow based on something called TCP window. And it's essentially the amount of data that TCP will allow you to send, and then you have to wait for an acknowledgement back, and then it will send another piece of data, wait for an acknowledgement. So as the geographic distance grows, so does your latency. And so what you end up with is a lot of waiting for acknowledgements and not so much sending data. And as you get geographically further apart, the problem grows. So it also, it detects congestion, and congestion means to TCP, lost packets. So it assumes if it sees lost packets that there's congestion on the network, and it slows itself down. So as you can imagine, with today's wireless world, there's a lot of other reasons why you might lose packets due to interference. You're on your cell phone, you're too far from the cellular tower, you're coming in and out of a Wi-Fi hotspot, or if you're on a satellite link, for example, there's interference due to that. So TCP and those types of networks will also throttle itself way back when the reason for the congestion or the packet loss is not congestion, it's actually interference on your links. So, and it's actually very aggressive in slowing down. The reason why it's so good at maintaining the stability of internet traffic is the same reason why it slows down so quick. But for a file transfer, you don't necessarily want that. You want to be able to tune the rate that it's transferring at. So again, it's very serial. It's like a conversation with one person on the other side of a room who maybe can't hear you at sometimes they can. And then you start adding middlemen in there who have to relay your message, and it takes a long time for you to get word back that they've actually got the message. And TCP is the foundation of FTP, SFTP, HTTP. Most of the protocols you use every day are all using TCP. It works great for shorter messages, but when you get into file transfer scenarios and you're actually transferring files over the internet and you're starting to get into higher bandwidths, that's when you start having this dead air. So enter UDP. UDP has been around as long as TCP has. It was meant to sort of remove all that congestion and flow control. It gives you a raw protocol that you can use for video streaming, other applications, gaming, but it has no reliability built in. It has no flow control built in. It has no congestion control built in. Packets can arrive out of order or missing. But one thing it does have that's very nice is the ability to send at a perfect stream as fast as you want, unthrottled, which is actually what you want when you're trying to saturate a link. So what most UDP solutions actually do is they take that UDP and obviously build reliability, build congestion control, build flow control, all on top of UDP at the application layer. So we're not doing it in the protocol stack, we're doing it in the application itself. So if you look at TCP versus UDP, these are just a couple of scenarios here of bandwidth recovery that you can make with most UDP solutions. When you're talking within North America, maybe coast to coast, without any tuning on your TCP, you can expect to recover quite a bit of bandwidth. So on a 45 meg link, for example, you're going to get close to optimal speed with most UDP solutions, open source or otherwise, and FTP is going to be choking without any tuning. So you can get a few open source tools. One's called Tsunami, another one's called UDT. We've actually gone through tests with these, and with minimal packet loss, they actually don't work too badly. The problem with the open source stuff is you don't get a lot of, well, obviously you don't get support. A lot of them don't have commercial friendly licenses, so if you wanted to embed it into a solution and then distribute your solution, you can't do that. Any modifications you make to it, you need to contribute back to the open source. And usually what they provide you is just source code or a command line tool that you need to compile from source. Not really ideal for distribution to a customer. But those options are there. If you need to move a file from point A to point B, you have a server on one end, you have a server on the other end, coast to coast, and you have a closed network. In a lot of cases, this will actually work for you if you want to take the time and compile it and tune it. And I guess the same could be said for TCP in a lot of cases. You can actually tune TCP to do similar things. It's when you get into kind of the many-to-one scenario where you have a lot of users who haven't installed anything, haven't tuned, and you need them to send files to you. That's when you start hitting scenarios where they're not going to be able to install a UDT or a Tsunami. They're not going to be able to tune their TCP. You're not going to have them download a lot of tools to tune their TCP and change registry settings in Windows to make TCP move faster. So that's when you get into some commercial solutions like FileCatalyst or Aspera. Constantly providing support, constantly developing. We have many applications that are built on top of that core technology to do things like watch folders. You have web-based applications to send an email to somebody, they get a link to come back, download the file. Many APIs for integration. So, and the commercial vendors obviously are going to provide you with 24/7 if you need it, integration help, and all the tools that you need. And then of course if you have features you need, you go back. You don't have to go through some open source forum to kind of request it, and then it gets added in 6 months if at all. So some considerations when you're looking at a UDP solution. It's got to play fair with other traffic. I mean, you don't expect it to react as fast or as nicely as TCP, and you don't necessarily want it to be as fast or react as quickly as TCP. You don't want it to have one or two packets drop due to interference and then suddenly cut its rate in half, right? But you want it to be able to play fair, so you want to be able to start up a stream of say, FileCatalyst or a UDP solution, and when you start transferring with FTP or someone starts using their IM or their web browser, they're not going to be screaming across the office that who's killing the internet or is the internet down, So that's a consideration to take, and you want to make sure that you test it well with maybe network emulators and just see how it reacts in the presence of other background traffic. 10 gig is coming very quickly to prominence. It's been around for a while, but you want to make sure that any solution that you're looking at is built for the future, so they can achieve 10 gigabits. And a lot of solutions will actually do 10 gigabits, but they combine 10 streams together to give you that 10 gigabits. So, unless you're always in that scenario, you might want to look for a solution that can transfer files at a full 10 gigs with one large file. Of course, you need to have I/O to support that on either end. You need to have the link. You need to have the machine that's able to handle it with CPU, your buses. Everything needs to be sort of high end, but you definitely want to verify those types of things when looking at a UDP solution. Another issue with a lot of file transfer systems is the case of many small files. So FTP, for example, will send thousands of files, but there's setup and teardown commands sent for each file that goes across the network. So if you're sending those on a 10 gig network and it's across the country, you're actually going to have dead air just from setting up and tearing down file transfers. So you want to look for solutions that provide at the application level ways to combine several files into one single transfer. So you're still getting your full 10 gig speed, but yet it's extracting the multiple files seamlessly to you on the other end. So, and of course, then the givens are the things like security, reliability, automatically resuming the transfers. So the open source solutions, for example, let's say you're halfway through a 2-hour transfer and you go and pull the plug on the network cable. What happens? Is it able to pick up and transfer the file from where it left off, or does it start and you lose an hour of transferring, or God forbid, maybe it's a day of transferring, and if your bandwidth is low and the files are massive? So you got to look for those types of things as well. And those resume, it's not just pulling the network, it could be anything that happens, So what a good solution should do is actually take a look at what's there, take a look at what you're sending, checksum the tail of the file, make sure that the relevant portions are still intact on the local side, it hasn't changed, and not just blindly append from an offset based on what's there. You can't just do that, because then you might spend another day and it turns out that the previous portion of the file was also corrupt. So, and then you got to look for things like automation tools, SDKs, central management. So if you just need that point-to-point, again, go to the open source. But if you need to have automation, so you want to have watch folders, you want to have email alerts, those are the types of solutions you get from the commercial vendors. If you want to integrate into your existing solution, that's where the SDK comes in. And then again, you have with the commercial vendors typically some sort of a dashboard or a console that can monitor all of your nodes that you have deployed, tell you what's going on. It'll integrate with your SNMP. It'll send you email alerts if a server or a node goes down and just let you know, maybe send you the error message along with it, and hopefully let you control those locations as well. So not just monitor, but manage each location from one central web console. So for integration into DAM solutions, I touched on little bits of it, but there's many ways. I've seen DAM solutions that have extensive CLI integration capabilities. So they can just they do an FTP or an SFTP command line, and they can plug in your CLI that you've generated from FileCatalyst or Aspera or UDT. But then a lot of the other ones want to have REST APIs. They want to have Java APIs. They want C++, .NET, Android, iOS APIs. So those are things to consider with your solution. Are you supporting mobile devices? Do you need to have file submissions from an iPhone? You won't get those necessarily with open source, but you'll get those with commercial. You want stuff that can integrate such that it doesn't necessarily interrupt your user experience. If you have a nice working flow right now with your solution and you don't want the users to learn a new workflow or learn a new application, you don't necessarily want something that they have to download and install on their desktop that changes the experience. So if you have a web-based tool, maybe a tool that integrates directly into your web page and you can control directly, and they don't actually see what's going on, they just notice the file transfers are faster. Okay. Cross-platform, cross-browser support. Everybody has web-based systems, so you want to make sure that it's not something that runs only in Chrome or only runs in Firefox, or you want something that runs cross-OS, cross-browser, and works in as many places as possible. Okay? And then central upgrades are a big one as well. So some ability to, from the client location after if they've installed something, ability to automatically update that. You don't want to end up having thousands of users you have to send a new installer to, and they have to go through the whole process again. So if it's a desktop application or a CLI or something like that, then you want to make sure it has some sort of a automated upgrade. If it's a web plugin, make sure that the web plugin has sort of a central file that when it loads the plugin, it can check and automatically pull down the latest files, and they get upgraded just by visiting the site again. So those are things to consider with the DAM solution. So just a bit about our solution. I mean, we have thousands of customers with all verticals. We have support for all the cloud deployments. Our support for the cloud deployments is different than some vendors. For us, we have a central cloud licensing server. You can install our application on any cloud you want to, and we give you a license key, and it calls back to our central licensing server and says, yes, you're licensed, you can run. So, and then we provide licensing options based on that, based on monthly. So we're not tying you to any particular cloud, or we're Amazon or Azure or whatever. One of the big things that we're doing right now is we've actually been doing a big push over the last year to do integration. So because of that, we've really extended and beefed up our integration options, whether it be our REST APIs, our Java APIs. We have web plugins, we have Java applets. All of those are there in our SDK. And we've actually put together an integration support team to aid in any integration that you want to do. Recently, actually, we were found by an independent study that compared 10 gigabit vendors to be the only vendor that was able to sustain 10 gigabits per second in the presence of high latency and packet loss. So, and for more information, you can just visit our website or follow us on Twitter or LinkedIn, Google+, whatever you want to do, or talk to me afterwards. And that's the end for me. I don't know if we're going to push questions to the very end.
I think we'll push questions to the end, and we'll move on to John Heaton.
Sure. Do you want
to
We probably have to switch.